So every year on March 3rd, it's World Wildlife Day. And you know the drill, right? We see all these beautiful images of tigers, whales, amazing rainforests. But let's be honest, if you're someone who designs and builds the modern world, an engineer, a planner, an architect, that whole conversation can feel, well, a little distant, kind of over there while you're over here dealing with the real world. Today, we're going to change that. We are going to reframe this entire discussion. We're taking it out of the ecology box and putting it where it actually belongs, in the engineering box. All right, so let's just dive right in. We're going to start with the core idea, the really provocative premise behind this whole explainer. Okay, here it is. Wildlife loss is engineered. Now, I know that sounds pretty jarring, maybe even a little accusatory. But hang on, this isn't about pointing fingers or laying blame. It's really just a statement of fact. See, the decline of all these species, it isn't some random, unfortunate thing that's just happening in a vacuum. Nope. It is a direct consequence, a direct result of the systems, the cities, and the infrastructure that we have designed and built. But, and this is the really crucial part, here's the flip side. If we engineer the problem, even if we didn't mean to, well, that means we have the power to re-engineer the solution. It means we can fix it. And look, this isn't about hitting the brakes on progress, not at all. It's about fundamentally changing how we think about design in the first place. So to actually do that, we need a pretty major shift in perspective. We have to stop thinking about nature as this separate thing, something pretty to look at over there. We need to start seeing it for what it really is, the single most critical piece of infrastructure we have. And for a technical audience, I think this analogy is going to click. Just think of biodiversity. That whole complex web of all living things. Think of it as the planet's core operating system. It is the foundational code that makes everything else run. And when that OS is running smoothly, when it's just humming along, look at what we get. All these incredible, absolutely essential services for free. It's regulating our climate and rainfall. It's stabilizing our soil and our coastlines. It's keeping pests and diseases in check. It's literally supporting the food, water, and energy systems that all of our own engineered stuff depends on. I mean, it's the ultimate public utility. But what happens when we start deleting lines of that code? When we start corrupting the system through habitat loss and messing with the environment? Well, it doesn't just show up as a sad nature documentary. It shows up as an engineering problem. It shows up in our project plans, on our balance sheets. We're talking flooded cities, buildings that can't handle the heat, serious water shortages, agricultural systems completely failing. A failing natural system doesn't stay out there in the forest. No, it triggers catastrophic failures right here in our human systems. What we've been calling an environmental crisis is, for all practical purposes, an infrastructure crisis in the making. Okay, so if we accept that, we have to ask the next logical question. How did we get here? How did our own designs end up degrading the planet's most important operating system? Well, the first thing to understand is this. The built environment is not neutral. Nothing we build is. Every single road, every pipeline, every building, it has an impact. And these outcomes, the loss of biodiversity, they aren't just unfortunate side effects. They are the predictable results of the design choices we've been making. So how exactly are we engineering this collapse? Well, we do it when we slice up vital habitats with new roads and cities. We do it when we push through new developments with poor land use planning, totally ignoring the ecological data that's telling us, hey, don't build here. And we do it when we rely on super resource-intensive construction. Every single one of those is a decision, and each decision contributes to the system failing. And this is such a powerful idea. Doing nothing is still a design decision. Choosing to ignore that ecological data or just failing to plan for the environmental impact. That's not a passive thing. It is an active design choice. It's a choice to accept the bad outcomes. It's basically a decision by default. Okay, so if the problem is a design problem, then the solution has to be a design solution, right? It's got to be rooted in a smarter, more data-driven way of doing things. And the first thing we need to do is get rid of this old stereotype in our heads. Modern conservation, it's not just about people with binoculars and boots in the forest anymore. Today, it's all about complex data sets, sophisticated modeling, and deep technical analysis. It's a field that now speaks the same language as engineers and data scientists. I mean, just look at the new conservation toolkit. GIS mapping, satellite monitoring, environmental impact modeling, climate simulations. Does any of this look unfamiliar to you? Of course not. These are the exact same tools that planners, designers, and engineers are using every single day. The data we need to design better, it's not some far-off dream. It's already here. And this really captures the huge paradigm shift we're talking about. The old goal for decades was just to avoid damage. It was reactive. Let's try to make this a little less bad. The new goal is totally different. It's to proactively design with nature. It's about integrating these natural systems into our plans from day one, not as some optional add-on, but as a core, non-negotiable component. So what does that actually look like in practice? Well, it's a pretty clear, actionable process. Step 1, plan your infrastructure around ecological corridors, not through them. Step 2, actively work to reduce your land and material footprints. 3, design for long-term resilience from the get-go. And 4, use all those amazing digital tools we have to visualize the impact before you build. You know, it's using that GIS data to route a highway around a critical animal corridor instead of plowing right through it. It's using digital twins to simulate what a new development will do to the local water systems before a single shovel ever hits the ground. All right, this brings us to the final and honestly the most important part of this whole discussion. Who's responsible for making this shift happen? First off, we just have to acknowledge the stakes here. The line between what we call environmental collapse and infrastructure failure is getting thinner and thinner every single year. We're getting to a point where they're basically the same thing. A world without stable ecosystems is a world where our own engineered systems simply cannot function. Period. So, you see, the responsibility for this, it doesn't just rest with conservationists anymore. The people with the most power to change our course are designers, engineers, planners, builders, decision makers. Frankly, it's probably the people listening to this right now, the ones drawing up the blueprints, approving the plans, and actually building our future. It's become a professional obligation. And so, this is the real question we have to leave with. It's the one we all need to ask ourselves. This isn't about whether you like nature or not. This is a fundamental question of design and function. Are we consciously, deliberately engineering a world that is resilient, that is stable, that is sustainable? Or are we, by default, designing a world that slowly erases the very operating system it depends on? The choice, really, is ours to make.